Hello everyone, this is Eren Şahin. I'm a sales engineer from liNear. Today's topic is construction and analysis of potable water and wastewater systems with linear solutions on Revit. I will use linear desktop water, analyze potable water and analyze wastewater modules in this webinar. Linear desktop water module will help you to construct your model very easy and fast. With linear view creation commands, you can easily create views and switch between them. With organized product libraries, you will have a wide variety of valves, pumps, dwelling stations, hydrants, and so on. And you can select these families in between generic or manufacturer-specific components. With dwelling stations and tank configurators, you can easily create your own product families and use them in calculations. There are automatic connection and routing commands, and also commands for detecting and resolving collisions. Potable water is a very important part of MEP design. Calculations are applied not only to transport the potable water to the tapping points, but also it should be inspected for hygiene requirements. Linear solutions assist you to analyze the system in both ways, based on universally accepted standards. These requirements concern tapping times, cooling or heating at non-operating times, disinfection, and many more. liNear analyzes potable water including the calculation of circulation according to DIN 1988-300/200. Water supply systems are dimensioned optimally and safely in view of hygienic quality of the potable water. And when you get your results, you can easily have legends, outputs, and material lists. With the wastewater pipe network calculation on linear analyze wastewater, you can hydraulically analyze gravity drainage systems for wastewater and rainwater within buildings, and dimension according to the standards. Drone slopes are checked, and optionally, the minimum slopes are used according to the standard. All pipe types are set by the program on the basis of the connection situation displayed in the drawing. The program detects the ventilation type based on the drawn pipe run. Moreover, all application limits, minimum lengths, and maximum number of bends are checked, as well as the maximum fall height. If the limit conditions are exceeded, the program reports the error with the corresponding notes from the standard. Now let's start to the live demonstration. As you see, we have a building model that all plumbing components are implemented. First, we will complete our pipe network. In order to do this, we should create a floor plan for potable water in the linear control board. Here we select the story, the discipline that we want to work on, and then the type of the view, and this should be a floor plan. And when we click on this green plus sign in here, we can specify details of this view. In this case, we have our view for this project, and we don't need to create another one. So let's move to our floor plan for ground floor. Now we will go to the construction tab. As you see, this tab is specialized for potable water discipline because we selected potable water when we were creating the view. We begin with choosing the reference level for our construction. We can select the floor from here, and then we can give a height value for this reference. Or we can use this command. When we click on this and select a component or a plane like this, it will take its construction level. To start drawing pipes, first we should select the system class. Here we have the pipe command. When we expand this dialog, we can select the manufacturer and the system. Here the manufacturer and here the pipe system. Also we can select the diameter that we draw and references for the construction. Now we will activate the command and start drawing. When we click on this, the command will be activated. And when we select here, we can easily draw this duct into our system. After we finish our cold water pipe, in most cases we must have our hot water and circulation pipes too. To make it more practical, we go to the parallel pipes command. Now we expand this dialog and click on configure. In this dialog we can set a configuration with pipes or ducts in different disciplines. We can also set distances, pipe diameters and insulation too. Now let's make a configuration with other potable water pipe types. We come to this potable water, we select circulation and potable water. As you see here, we can set a diameter, a distance and insulation. After we finish our configuration, we will click on OK. Here we can also set a reference and the distance for clear distance or axis distance. When we activate the command and select the pipe, as you see, it will give us some options. There are 4 options. This is the first one, the second one on the other side, the third one is on top, and the fourth one is at the bottom. And after we select one of them and click on apply, pipes will be drawn. Of course, we don't need them for this project. After we create our pipes, we will connect them with components, and for this we will use Connect Components dialog. Let's close these ones and expand Connect Components. Inside this dialog, you can select different variations for connections. You can use crossovers, you can set up distances, you can apply ear elbows and loops for each pipes. After we do the desired selection, we can activate the command and select components that we will connect. For this case, we check the Spend on Lost Components and we activate the command. We do the selection like this, and when we click on Enter, as you see, all components are connected. Let's look at them closely. Here you can see the connections are made as we wished. Now let's go back to our view. Here we have a pipe offset command. With this, we can easily resolve collisions. First, let's check out the details. Inside this dialog, we can set distances for X and Y. Also, we can set an angle. Another option is if you check this box, this command will use the existing fittings to create the offset, and you will avoid to use extra fitting. And if you select if you consider insulation or not. Besides, we have 3 modes. You can apply this offset around elements, linked elements, or manually. liNear will detect if there's a linked element and apply this offset around it. Now let's go to the 3D view. Here there's a collision that we can execute our command. As you see, it's right here. First, we activate the command. And we select the pipe that we want to offset on. and then press on enter. And then we select the other pipes. And when we confirm, it will give us two different options. And when we apply one of them, the command will be executed. We also have a legend command. If you want to create a legend, you can easily click on this command and select accessories, fittings, fixtures, or equipments that you want to see in the legend. You can also select system classes in here. Here you can write a headline and configure text styles. In the Arrange and Rename tab, you can change descriptions of materials as you wish. When you click on OK, it will create the legend. As you see, all materials and pipes are taken in this legends list. There is one more command in here. If you want to divide your pipes and create sections, you can use this command. When you enter values for section length and minimum length and activate the command, and when we select a pipe, for example this one, and press enter, it will divide this pipe into sections. In the next tab, we have product libraries. As you see, there are different kinds of components that can be used in potable water. These components in here are neutral. They can easily be implemented into the project. When you open it and click on it once, it will be preloaded into the project. And when you click on it one more time, it will appear on the crosshair and you can place it wherever you need in the project. There's also the liNear CAD browser. When you click on it, it will open as another software. And as you see, there are different manufacturers. Let's select the Oventrop. As you see, there are valves for heating and potable water. Let's select this one, and backflow protection devices, and this one, and when we select the diameter, in here we can see the preview of this component. Also, there are technical data in here. And in here, there's an option for the connection type. You can select the male or female thread for this component. You can also set the level of detail that you want to see in your model. When you place this component into the CAD, all of the technical parameters will be transferred with the component. Besides these, you can of course use your own families with linear analyze modules too. All you need to do is create a family according to Revit rules with right connections and flow type, and you can place it in your project, and when you analyze your project, linear will calculate it as a component too. Now let's go back to the CAD. In the Library tab, there are also configurators. First one is dwelling stations. If you will use a dwelling station in your project, you can select the manufacturer and the product in here. And then you can set up requirements for the device. When you click on this, you can set values for hot water, tap rate, heating capacity, and supply water temperature. If the device you selected has floor heating feature too, like this one, you can set values for supply and return water temperature from here. Also number of circuits, heat capacity, and so on. You can also select the accessory material from here. If you want to draw the dwelling station in the project, you can just easily click on Draw command and it will appear on the crosshair. Here we also have a tank configurator. Here you can set up the type of the tank and you can check it out from the preview. We can configure it vertical or horizontal. Also, we can create ports from here. We can create these ports on body, on bottom, and on the top. When we create a new port in here, we can enter values for the height from the reference plane, and we can select its exact location with the coordinate system in here. Moreover, we can do the system selection in here. When we click on Draw, the family will be created with the parameters that we give. If there's a tank that's already drawn and you want to make some adjustments, you can go to the dialog and click on this Get command, and when you click on the tank, you can easily do all your changes. Before we start our calculation, let's check out the configuration. First part, there are system types and components that detected with liNear for this discipline. As you see, system types with PW initials are detected for components. PW stands for the potable water. Down below, we have our calculation parameters. We select between these four standards for Germany, Switzerland, and Russia. When we change the standard, liNear will notify us about the methods that will change. And in here, we can give values and conditions such as maximum velocities and pressures for our calculations, and of course, we can change units in here. In units dialog, we can load different units that can be used worldwide, and we can select the accuracy for each unit. Now we will click on this calculation. As you see, the calculation dialog is here. It has categorized results in three titles. They are flow paths, section parts, and components. When we select the flow path, we can see section parts and components on that flow path. When we expand this dialog, as you see, there are two rows marked in green and red. These shows us the critical flow path for cold and hot water systems. When you select the flow path and click on Show, it will show it on the CAD model. When you click on Search and select a component or a pipe, it will show you the flow path, the section part, and the component on this list. When we click on Edit, as you see, it will show parameters for the component. You can set a condition for peak flow rate, you can set minimum flow pressure, flow rates for hot water and cold water, and minimum connection diameter. From the other tab, you can adjust flushing settings such as time of operation and usage frequency. As you see, this report button is orange. It means that liNear has a warning. If it was red, it means that there's an error in this project and the calculations cannot be completed. But for this case, it's only a warning. When we check it out, as you see, it says that we should put a shutoff valve before and after the flow divider in this project. But calculations are completed without these valves too. You can also check out these warnings from here. In the Issues and Task tab, you can see these issues are already displayed in here. Now let's go back to our calculation. No components are added or removed from this pipe network, so it doesn't need to calculate again. As you see under the section parts, all pipes are dimensioned and the system is hydraulically balanced based on these boundary conditions that we gave in the configuration. If you click on these three dots in here, you can set a minimum pressure for the tapping clamp and zeta value for this component for the system. Here we have hygiene functions. The first one is the ambience. Here you can have the simulation of network temperatures and the assignment of insulation material and ambient temperatures. In this tab, you can modify ambient temperature, insulation data, and pipe material in order to simulate load cases in network temperature and circulation simulation. And on this tab, you can display the temperature profile of individual pipe or the entire pipe system. Another function is the ejection process. It shows the ejection process of hot water consumers. It determines for individual hot water consumer after the time the hot water ejects after the preset testing temperature. As you see, this diagram simulates the process. In the hygiene status command, you can illustratively display the hygiene properties and rinsing properties of specific hygienic flushing devices and normal components in the model. If you click on Show Status, it will visualize in which story a flushing device cares for hygienic correct states. Also from here, you can see the rinse velocity. You can also visualize the flow type and the Reynolds number for the flushing device. Or if you check this box, you can select any component and see these values. Here we also have a peak flow rate command. The peak flow rate is calculated for each section part individually based on the calculation flow rate and the selected building type from the configuration dialog. You can specify the building type either in the configuration for all section parts or for each section part individually in this peak flow rate dialog. Also, there is a visualization command. With this command, you can color the pipe network based on the selected parameter. For example, if you select the velocity, it will color the network in a color palette that's blue to red. And when you click on display, as you see, the results are visualized. And if you select another value, such as nominal diameter, it will color all network with different diameters with different colors. If you want to see details of circulation system, you can change the system type from here. The calculation dialog shows an overview of the detected pipe circulation systems and contains all functions necessary for the calculation. The concept is very similar to the potable water system, but of course there are specialized functions. For example, if you check View Thermal Disinfection box in here, the water temperature will be raised to 75 degrees, and circulation pipe network is calculated using this temperature without changing the nominal pipe sizes. If you are not sure how to use these functions, you can simply click on Help. From here, you can find every information about functions, tables, and calculations. All interface is context sensitive and user friendly. Now let's see other comments on our Analyze tab. Here we have pipe tables. You can select diameters and types of pipes that you will use in your system. You can limit these diameters and they won't be used in calculations. And here we have a valves command. You can do a pre-selection for valves that you will use in your system. Data from different manufacturers are available for this purpose. If in valve pre-selection you have selected more than one valve for the same valve type, the most suitable valve will be calculated and automatically inserted. In the local assignment, you may select and assign valves that deviate from those selected in global pre-selection. We also have pumps command. If your pipe network contains a pump, its data are initially neutral. The required delivery height and the required flow rate are calculated by the program. And in here, you can select a pump that supplies the requirements and it will be used. If a pump in your model has a manufacturer pump assigned, the data of the selected manufacturer model will be used for calculation. In Output Command dialog, you can select titles that you want to see in the output. And we click on Preview. As you see in the output, we have a page for critical flow path. We have list of valves. We have pressure losses for each flow path, and we continue to each section part. And when we go on, we see pressure losses for each flow path in more details. When we continue, we can see the ejection times and hygiene statuses. We see the circulation system in detail. And in the end, we have the material list. And now I will show you how to analyze wastewater systems with liNear. As you see, we have a drawn wastewater system in here. Wastewater pipes are drawn and connected with components. We see the Analyze tab in here. First, we will check out the configuration. In the first tab, we can specify global settings for the detection of components and pipes that are to be considered during calculation. In the second tab, you can determine global settings for calculation. When you select the calculation method and building type, of course, liNear will analyze the system based on this selection. You can also specify minimum slope and determine global settings for technical data of toilets. Also, we have some other options in here. These are about inside radius, filling levels of lifting stations or open pit. Also, there's an option for slopes. If you check this, liNear will ignore slopes on the construction and do calculations as if there were slopes. If you uncheck it, it will ask you to insert a minimum slope when the one on the construction is too small. In the third tab, you can specify all settings regarding to the rainfall rate that is to be used for rain drainage. You can import rainfall data of desired location from the Costra DWD software. Here we also have pipe tables like in potable water, but these pipes are for wastewater systems. Here you can do the selection and these pipes will be considered in calculations. And now we will go to the calculation command. As you see in here, like in potable water, we have all calculation results are listed as flow paths, section parts and components. Also, as you see, the report button is orange. That means that liNear gives us some warnings but not errors. Let's check them out. It shows us that some section parts are exceeding the permissible pipe length that we set on the configuration. Also, it shows that we used more bends than permissible limit, and it automatically increased the minimum slope of this collection pipe in order to fulfill the requirements. As you see in here, liNear not only analyzes the system, but also assists you to understand what's going on, and it will lead you to make your construction much more accurate. If you want to visualize these results, you can go to the visualization comment. In here, you can color the system based on different parameters. You can visualize slopes in the system, and it will show you all slopes in different colors. And of course, in here, you can visualize the pipe type too. Here, you can see all collecting pipes and downpipes in the system are in different colors. And of course, in output comment, you can also have outputs like we did in the potable water. As you see, all results are listed in here. We have come to the end of this webinar. Today we constructed and analyzed potable water and wastewater systems on a 3D Revit model. I used linear desktop water, analyze potable water, and analyze wastewater modules in this webinar. If you have any opinions on our webinar, or if you have any suggestions for topics that we should cover in our next webinars, please let us know. If you need more information about this subject or linear, you can reach us via export@linear.eu. If you want to watch this or previous webinars again, you can follow linear YouTube page. Thank you very much for your participation. Now please feel free to ask your questions.